What we're going to do is move from solving equations to solving inequalities. We're going to be looking at creating inequalities and solving them. Now, when we're creating them, what we need to do is just go over a couple words. What we have is the less than sign. Sometimes it means below. This is less than or equal to. This word is used a lot in algebra, at most. So whenever you hear at most, we're going to be using the less than or equal sign. If we think of it, if somebody does at most 5 push-ups, that means they do 5 push-ups or less. So that's what it means by at most. Greater than, more than, or above, greater than or equal to, or at least. This is another key word that's used a lot, is at least. And then, of course, we have not equal to, means that it's anything but equal to the specific value. So we're going to be writing an inequality, and we're going to represent it from the description above. So we have Joey Chestnut, which we're going to use as J, is a competitive eating titan, clinching his 11th win in Nathan's famous hot dog eating contest. This was at a specific date, so it might be broken, which takes place every year on July 4th at Coney Island. Chestnut ate a record of 74 hot dogs and buns, up from 72 in 10 minutes, beating his own record. How many hot dogs and buns must he eat to beat his record? Now, notice it says beat his record. He doesn't want to tie his record. He doesn't want to do less than his record. He needs to beat his record. Notice they're telling us the specific variable. So we're using the letter J, and he wants to beat it. That means it has to be more than. His current record is at 74, so we're going to put 74. And that's how we're going to write our inequality. For this next one, it says twice a number n is less than 12. So twice n would be 2n is less than 12. Here we have it set up. We're going to solve it by dividing by 2, and we get n is less than 6. It says 3 times the sum. Now notice that we're multiplying the sum. So we're multiplying 3 times the sum of a number. They're telling us to use p and 14. Now notice it says at least. Whenever it's at least, it would be greater than or equal to, and in this case it's 30. I'm going to divide each side by 3, and I get p plus 14 is greater than or equal to 10. Then I'm going to subtract the 14, and what I get is p is greater than or equal to negative 4. Now, you could have also distributed the p to each of the terms and have gotten 3p plus, that gives us 42, and done the same thing to get the same answer. Sometimes what I like to do when I see it in parentheses is just get rid of it right away if it goes in evenly. If this number was like 31 and I got a fraction, I definitely would be distributing the 3 instead of dividing by 3 at the beginning. And what we have is an ESHS student has at most $100 to spend on clothes. If she has to buy one pair of $30 jeans, how many $5 shirts can she buy? And we're just going to pretend there's no tax. So we have $100 to spend, and that's at most. So it would be less than or equal to 100. She has to buy one pair of jeans, so we know she's spending $30. We don't know how many shirts, so I'm just going to use X. S would make more sense for shirts, but my S's and 5s look the same, so I'm just going to use an X that's a little bit easier for me to distinguish. I'm going to subtract 30 in order to solve this, and I get 5x is less than or equal to 70. I'm going to divide it by 5. And so when I divide 70 by 5, what I end up with is 14. Now what we're going to do is we're going to look at just solving these. So when we're solving these, we're just going to solve these just like a normal equation. We add 1 on both sides, and we get 5x is less than or equal to 4. And then I divide it by 5, and I get x is less than or equal to 4/5. For the next one, I'm going to distribute the negative 3 to each of the terms. I'm going to add the like terms. I'm going to subtract the 5. And I'm going to divide by negative 3. Now, when I divide by negative 3, what's going to happen is I'm going to switch the inequality to greater than or equal to, and I'm going to put negative 1. Now, why I'm switching the inequality is because with an inequality, if we have two numbers, let's say 2 and 10, and I subtract it by 2, that would be 0 and 8. So I know that 10 is bigger, and still 8 is bigger than 0. Now, on the other side, though, if I have 2 and 10, and I know 10 is bigger, and I divide it by negative 2, what I end up getting is negative 1 and negative 5. Now, in this case, notice that the negative 1 is greater. So what happens is whenever you multiply or divide by a negative, the values of the inequality actually switch. So we have to remember that when we divide, it's actually no longer going to become less than. In this case, it's going to become greater than. And that's why we switch the inequality. So with this one right here, I'm going to distribute the 3x, and I get 3x minus 3 is less than or equal to 5x, and then plus 20. I like my x's to be on the left-hand side of inequalities because when we move into graphing, it's going to be a little bit easier. So I'm going to subtract the 5x. I get negative 2x minus 3 is less than or equal to 20. I'm going to add the 3. And I get negative 2x is less than or equal to 23. And then I'm going to divide it by negative 2. Now, when I divide it by negative 2, remember, once again, whenever I multiply or divide by negative, what happens is it switches the inequality, and I have negative 23 over 2.